RLHF is a technique that involves fine-tuning LLMs based on feedback provided by humans on the labels. Human reviewers rate the output of the LLM on prompts, and these ratings act as signals to fine-tune the model to generate high-rating output. RLHF brings humans into the loop to steer the LLM in the right direction and ensure that the generated text aligns with user or application requirements. Reinforcement learning from human feedback is an approach in artificial intelligence that combines reinforcement learning techniques with human guidance to improve the learning process. RLHF involves training an agent or model to make decisions and take action in an environment while receiving feedback from human experts. The goal is to optimize the model's performance by leveraging human feedback as a measure of performance or even as a loss to optimize the model. RLHF comes with 3 stages in order to get the final model. In the pre-training phase, the model is trained on a large corpus of publicly available text from the internet. This helps the model learn grammar, facts, and some reasoning abilities. However, it doesn't have specific knowledge about the prompts it will later receive during fine-tuning. The output from this stage is pre-trained LLM. After pre-training, the model goes through supervised fine-tuning. In this stage, the engineers perform fine-tuning on the pre-trained model using a dataset that consists of human-generated responses paired with high-quality prompts. This dataset is created by human labelers who write tens of thousands of prompts and example responses. The model is trained to generate responses that align with the provided examples. The goal is to make the model more intuitive and better at following instructions. The third stage of training is RLHF, where the model is fine-tuned further using reinforcement learning techniques and human feedback. RLHF incorporates human feedback into the rewards function of the model, allowing it to optimize its decision-making process based on the feedback received. The reward model is trained using comparisons, where response A is deemed better than response B without specifying the degree of improvement or the reasons behind it. RLHF helps address issues like hallucination, where the model generates responses that are not accurate or reliable. By having a better reward function, the model can be punished more for making things up, reducing the occurrence of hallucination. The process of training the reward model in RLHF involves several steps. First, a large dataset of prompt-response pairs is collected. Human annotators are then tasked with ranking these responses based on their quality. These rankings serve as the ground truth for training the reward model. To train the reward model, a supervised learning approach is employed. The fine-tuned model generates a set of responses for each prompt in the dataset. The human evaluators then rank these responses, providing a numerical score for each one. These scores act as labels for the reward model. The reward model is trained to predict the reward score given a prompt-response pair. This is achieved by minimizing a loss function that measures the difference between the predicted reward score and the true score provided by the human evaluators. The model is trained using gradient-based optimization techniques, such as stochastic gradient descent, to iteratively update its parameters and improve its performance. By maximizing the gap between the reward scores of chosen and rejected responses, the reward model learns to distinguish good responses from bad ones. This allows the RLHF system to generate high-quality responses by optimizing the policy based on the predictions of the reward model. During this process, random prompts are chosen from a distribution and feeding input into the LLM model to generate a response. The response is then scored by the reward model. It is important to impose a constraint during this phase. The result from this model should not deviate too far from both the models obtained in the supervised fine-tuned model and the pre-trained model. It is important to strike a balance between generating high-scoring responses and maintaining the consistency with the SFT phase and the original pre-training model. This is achieved by introducing a constraint in the training process. The constraint ensures that the model does not deviate too far from the previous phases, preventing biases towards responses with extremely high scores that may not necessarily be good responses. Reinforcement learning from human feedback is an approach that combines reinforcement learning techniques with human guidance to improve the learning process. It involves training an agent or model to make decisions and take actions in an environment while receiving feedback from human experts.